Hey guys, let's go over problem 23. All right, so what happens on problem 23? I don't know. It's probably asking about some synthetic divisions or just like basic algebra. Now, P of x equals, now we got P of x. All right, so let's just try to write it P of x. That has been equal to x cubed plus 4x squared, and we get plus 7x, and we're adding it with 1. Okay. So we have these, the polynomial. And I need to find out P of x plus 1 in order to come up with x cubed plus ax squared plus bx plus c and determine a plus b plus c. Okay, so there must be multiple ways of solving this. But apparently, in order to solve it like quickly, I'll show you two possible solutions for this one. P of x plus 1 is in fact q of x. Okay, so this is q of x, and I'm looking for x cubed plus ax squared plus bx plus c. Now, you should notice that we're not asking, or this question is definitely not asking you to find the individual values of a and b and c. So probably there must be a good way to figure it out. Now, the first way to figure this out is that we plug x equals 1. So if you plug x equals 1, well, q of 1, well, this will be just 1 cubed plus a times 1 and b times 1 plus c. So what is then q of 1? Well, we know that this is going to be turning into p of 2. And do we know how to find p of 2? Obviously, I would say. So we know how to find p of 2 in this following form. So for an instance, p of 2 will be in fact 2 cubed plus 4 times 2 squared, right? And plus 7 times 2 and plus 1. Okay, so these are turning into 8 plus 16 plus 15. Let me just do mental math real quick out here. That becomes 31, right? These becomes 31, so we get 39, right? So here we go. We have found 39 out there, and is there anything that we can try? Well, we got to first find out that a plus b plus c equals these expressions out there. So 1 plus a plus b plus c is exactly equal to p of 2. And if you write it down accordingly, those are p of 2, right? So if you found p of 2, well, obviously, a plus b plus c supposed to be just 38, okay? All right, so we found 38. That becomes the answer. This is one way of solving it. I'll show you another way of solving it, okay? So what if we try synthetic division? What if we try synthetic division, like ST? Now, this is going to be like really, really good example of using synthetic divisions in this nicer format. And here's how we're going to try, okay? So we can actually give it a shot by writing positive 1. Check this out. You can actually, this is a good exercise to see why it works. It becomes 1 and 4 and 7 and 1. And you perform all those synthetic divisions like multiple times. Like this is cubic equation, so we're going to try out 3 number of times. So that becomes 1 and 5 and 5 and 12. That becomes 12 and 13. And don't stop in the very first line. You got to keep doing this process. So if you keep doing this process, that becomes 1 and positive 6. 6 out there, and that becomes 18, right? And you got to try it once more. Positive 1, so 1 and 7. So right now we have found from this examples, from all of these numbers, we have found some list of numbers, right? We have found all those list of numbers, and that becomes the coefficient of q of x. So p of x plus 1 is in fact equal to 1 times x cubed plus 7 times x squared plus 18 times x plus 13. Okay, so now this time I want you to try to call this as a, try to call this as b, and try to call this as c. What do you get for a plus b plus c? You get a plus b plus c equaling 7 plus 18 plus 13. And that is indeed equal to 38. That's another way of solving it.